Okay, thank you. And we're here to with our presentation. We have Andrew Bonney from the BBC, who's going to be talking about identity and timing, another really important feature of NMOS. So take it away, Andrew.
Thank you. Right. Hello, everyone. Thank you for coming along today. As Wes said, I'm Andrew Bonney. I'm a research engineer with BBC Research and Development. I'm going to be talking a bit about identity and timing in the AMWA NMOS specifications. And this is an activity that we've been running for a little while now. I'm going to talk a little bit about, first off, what identity and timing is as a concept, what we've been doing in the activity over the past year, and then also a bit about how it might help us achieve some new technologies, some new changes to workflows in the not too distant future. So first off, this is an AMWA activity that we started around this time last year, so I've been running for about a year now, and as with all AMWA activities, it involves a mixture of vendors and end users, so we can get a mixture of opinions there. What we've been trying to do is to look at how we can identify content in a system. So we associate identity and timing data with pieces of content rather than just pieces of equipment. And we want to be able to persist that identity and timing data from end to end in the system, so right from capture through to consumption. This work has been based on something that started in the AMWA NMOS specifications in the very early days. So we had something called the NMOS content model, and that's something that was a foundation for a number of the early specifications, including ISO 4, and I'll talk a bit more about that later. But what we wanted to do as part of this activity was to go back over that, to refine it, and to turn it into a specification in its own right. So we've been trying to clearly document the models that we've come up with, feedback any results of any changes to any of the existing AMWA specifications, and then we want to look at some of the important stages beyond that. So how might we start to include this identity and timing data along with transports like 702110, and also potentially in file format, so stored content. The main thing, as I say, is that this is a potentially very big enabler for new technologies and for changes to the way that we conduct our workflows as we're adapting and moving into IP systems and potentially beyond. So just to start off with an introduction to what these concepts are, when I'm talking about identity, I'm talking about the ability to uniquely identify any resource in your network media infrastructure. And that could be physical things like nodes, senders, and receivers. But in this particular case, what I'm interested in is the identity of the content, so the video, the audio, and data that we have that has business value. And what we want to be able to do is to uniquely identify every piece of that content, but also we want to be able to identify how it relates to the other pieces of content in the system. So is it another rendition of the same piece of content, maybe just at a different bit rate, or is it something that's completely unrelated? Now, there are some real-world examples of similar approaches to this, and cases where you might not know that these concepts of identity are being used, but they help to mask some of the technical complexity. So if we take a look, for example, at video on demand, if you're consuming a television program from a streaming provider, you'll go and look for that program and start consuming it. And as you're consuming that content, it might switch between several different bit rates that are available for that single piece of content. The idea there, of course, is to make sure that it's matched up to the bandwidth that you have available for your internet connection. But all you've had to do as a consumer is to identify the single piece of content that you're interested in. You don't have to manually switch between these different bit rates. You can let the system under the hood worry about that. There's a similar situation with content distribution networks. If I want to download a particular file from the internet and are using content distribution network, then that content distribution network will work out where is the best place geographically to get that content from. I don't need to worry about that as a consumer. I just get the best possible experience. So how about timing? Well, this is something that's perhaps a little bit more familiar, and it's something that there are aspects of in the existing SMPTE 2110 specifications. So this is about associating unique time values with every video frame, every audio sample, and every data element that we're processing in our media system. And obviously, one of the big advantages that we can get from doing this is we have the ability to automatically resynchronize this content no matter what processing elements it's gone through in the system, so we can re-achieve lip sync. Another potential benefit to having this timing data built into all of our streams, all the things that we're carrying around, is that not every single process in the chain has to have access to a precise source of time. If they're just performing a one-to-one operation and carrying that timing data through, then they don't need to do anything special beyond that. So why are these things complicated? Why are we doing this activity at all? Well, the big challenge with end-to-end identity and timing, and particularly the end-to-end aspect of that, is that it requires a consistent approach across all of the media ecosystem, everything that's operating in your facility. So whether it's a production switcher, camera, they all need to interact with these things in the same way. And if we take a look at an example like a production switcher, this is one of the particularly complex cases. I've got many different things coming into that device, and I've got potentially a few things coming out. It's multi-in, multi-out. Each of the things that's coming in there has its own unique identity and timing data, and we need to decide what is the most appropriate way to carry that data through to that output. Do we need to carry through all of the data that arrived? So if I'm mixing together two different inputs in one go, do I carry all of the data associated with those two inputs? Or do I do something that's a bit different? So these are some of the areas that we've been looking at as part of this activity and trying to work out the best practice for how we handle this data through all sorts of different types of equipment and different facilities. The other thing to note is that this isn't something that's completely new to RTP and to 2110. I've mentioned already that 2110 makes use of some aspects of timing, so it uses the RTP timestamp, which is baked into the header of RTP, and that's used to enable us to do an amount of resynchronization of streams, so for the related video, audio, and data. But what you might not know about RTP is it also has an aspect of identity in there. It has something called a synchronization source identifier and contributing source identifiers. And these aren't something that we're making use of, but the original intent of these was to model things like mixers. So at the output of a mixer, I could identify every source that contributed to that particular output that I'm viewing at a point in time. The thing that we view as important as part of this activity is that in the future we're going to need solutions that aren't locked to a single technology. So we're not locked to just the transport of RTP. We could work with any potential transport in the future and any potential stored content format. So we want to define a model that sits above all of these formats, and then we can map down onto them as and when we need to. So I've talked a little bit there about what identity and timing actually are, but you might be wondering, what are some of the potential benefits that we can actually get from this approach if we were to adopt it? So there are a whole range of these, and I'd suggest that the biggest benefits come from some of the future technologies that we might want to look at. I'll come on to some of those shortly. But some of the more near-term benefits are in areas such as, for example, remote production. Now, you'll see a number of demonstrations of remote production technologies across the show today, and these are covering obvious use cases. So obviously sending large production teams to venues is very expensive, restricts the number of events that we can cover. But typically these solutions will be either proprietary, they might use a coded video format, for example, reduced bandwidth, so you're getting a reduced quality at your output. Or even if they're not doing that, then they'll require a very high bandwidth link between the remote site and the facility where you're doing your production operations. One of the benefits that we've demonstrated through our research is how we can get the best of both of these worlds by attaching this identity and timing data to the content. So this is a diagram from a demonstration that we did in 2014 as part of the Commonwealth Games in the UK. And in this situation, we had a number of ultra-high definition cameras that were capturing video content. But the key difference to a traditional setup here is that alongside that ultra-high definition content, we were also capturing lower resolution versions, so high definition and standard definition. Alongside each of these streams, we were associating identity and timing data with them. So in the same way that we could do today with a 2110 stream, we modified those 2110 type streams, attached the identity and timing data, and then we could do interesting things with that. So in this particular case, rather than sending the full quality version of those cameras straight back to our base end to mix on that, we just sent back the SD or the HD versions. We performed our edits, our mixes, switches, and then we recorded the decisions that we made against the timestamps for the different video streams that we were receiving. We could then pass that data back to the remote site, and we could conduct a full ultra-high definition production switch against the content without it ever having left that remote facility. And we can do that in a frame-accurate fashion because we have that identity and timing data baked into the streams. So that's an idea of how we could adapt some perhaps current technologies to take advantage of identity and timing. But what about the things for the future? Well, one of the big hot topics that we'll be seeing growing up around NAB and elsewhere is the move to the cloud. And cloud architectures offer all kinds of possibilities for advancing our technology and our workflows. But one of the key things to note here is that when I talk about cloud, I'm not just talking about virtualizing the same technology that we have today. I'm not suggesting we take the media nodes that we have, virtualize their capabilities, and just plug them together in the same way we have before. Cloud is about something very fundamentally different, about architecting our systems in a very different way. And if in these situations we don't have access to things like IP streams and SMPTE 2110 within that cloud environment, then we're going to need a different way to refer to our content. And this is where we see one of the big benefits of having this identity and timing model, in that we can refer to our content and then we can tell the system exactly what we want to do with that content under the hood. Another potential benefit to this identity and timing approach in the future is what we can do in the home. So it's not just about adapting things for the production side of the situation. We have the possibility that we could do things like elemental distribution. So like how SMPTE 2110 splits up the video, the audio, and the data in the production facility, we could also do that to the home. We could send the video, the audio, and the data separately, and we could resynchronize it when it gets to the other end. One of the big benefits that we could get from doing this is the ability to do some client-side rendering. So we don't have to bake our entire program in the production facility. We can send it in parts to the end user, and it can be finished off at that device, provided we've got the confidence that we can resynchronize all of that media together. So there are a few examples of how we could take advantage of the benefits of this approach, but where have we actually got up to in the activity so far? So I mentioned that this was based upon the existing NMOS content model, and that uses terms such as sources and flows, and these are used to refer to the pieces of content that we're processing. So we've been building upon those definitions, and we've also been looking at common production operations and working out how we persist that identity and timing data from one end of the system to another. We've also been looking at defining time values and how we relate those to the content, the individual video frames, audio samples, that sort of thing, and how we persist those through devices, but also what we should do at the boundaries of a production or at the boundaries of a facility. So if I have an outside broadcast, should I be persisting those time values all the way from the OB through the facility? As a result of that, obviously, we've been making recommendations for how we carry identity and timing data from end to end in these environments. And this has all culminated in an AMWA specification for identity and timing, which has the identifier MS04 for Model Specification 04. And that's in the process of being ratified by AMWA at this point in time. Now, I can't share all of the details of this specification. There's a lot of detail within it, and it's all available to the public now. I'll share a link to get at that very shortly. But I wanted to share a couple of the basic concepts that are contained within it. So I've mentioned the terms sources and flows, and just to give a very basic example of what this allows us to do, if we take, for example, a video camera, so a camera capturing content from a particular scene, we might associate a source identifier with that camera's output. Now, that camera might be producing an ultra-high definition flow in an uncompressed format, but it could also be producing for us a compressed version at high definition. The key thing here that we have available to us is by having these flows joined together by that common source identifier, we're able to identify that they are equivalent versions of the same thing. So if I go to the same timestamp in this flow on the left-hand side, and I switch over to the flow on the right-hand side, I'll get exactly the same video frame of exactly the same point in time. So that's one aspect of the specification. That's more about the formal concepts that are defined. The other side to the specification is looking at all of the production operations that we handle and exactly how we pass this identity and timing data from end to end. And we have a number of examples, diagrams that we've been working through, and timing diagrams, for example, that talk through exactly how the timing data should persist from end to end in the chain. So how does this relate to the existing AMWA specifications, things like ISO 4, ISO 5, that sort of thing? Well, we're building on the common concepts of sources and flows, and these have existed in specifications like ISO 4 from day one. So if you're deploying a system today that includes ISO 4, then you're already getting some of the potential benefits of this approach. The key thing that's missing is the ability to persist this identity and timing data from end to end in the system, so through the streams, through the file formats, and that sort of thing. And to show an example of what that looks like, I have a camera on the left-hand side here, which is capturing some content, and it's NMOS enabled. And as a result of that, it's giving the content a source ID and a flow ID. Unfortunately, however, as it's passed onto the network, there is no way to attach that metadata to the stream as it passes through the system. And so as I transition through the network all the way to the display on the right-hand side, Once we reach that display, it has no idea of exactly where that content has come from. It doesn't know that it came from this particular camera. If we take a look, however, at a slightly different example, and this bottom example is making use of the AMWA event and tally specification, ISO 7, the difference in this case is that because the payload specification for ISO 7 has been built from the ground up, we've been able to include in that the identity and timing data from day one, and so we can persist that in stream all the way through the system. What this means is that if I have a microphone, for example, and it's capturing some level metering data for me, it's got a source ID, it's got a flow ID, and I can bake that into the data that's passed through the network, passes all the way through the network, potentially through some processing devices on the way through, and I get to a level meter display on the right-hand side. That level meter display then knows exactly which microphone in the system that content has come from. And we can do all sorts of interesting things that I've been talking through already as a result of that, but there are even some very simple things that we can do as a result of having that data. I could, for example, go to the ISO 4 registry and look up an appropriate label to display alongside that piece of content. And as I make switches around, I change which source that particular meter is connected to, it can dynamically adapt that label to match the source that it's subscribed to. So what's next for this activity? We've been through essentially phase one of the activity now. That's taken the past year, and we've defined this model specification. But the big next step is about how we get this identity and timing data more consistently into the transports and the file formats that we're using. How do we map it into things like SMPTE 2110? Now, there are already some activities going on in SMPTE, for example, in order to transport metadata alongside SMPTE 2110, and it's possible that we'll be able to include some of these concepts in that sort of way of working. Another thing we're likely to need to look at in the future is the definition of content APIs. So particularly as we're starting to look at these new cloud workflows and a completely different way of building our production architectures, we're going to need this common way to get content in and out of those ways of working. And so having content APIs built upon these concepts of identity and timing give us a way to achieve that. A key thing to underline all of this is that it absolutely needs buy-in from both end users and from vendors. It's quite a seismic shift in the way that we process things, moving away from a connection-centric view of the world into a content-centric view of the world. And if we don't have agreement from everyone that that's the best way to go, then we're simply not going to get anywhere with it. I'd just like to leave you with a couple more examples of some of the things that we've been able to achieve as a result of having this identity and timing data available. So these are things that we've built as part of our research work, and we've been using technologies like NMOS ISO 4 under the hood and streams much like SMPTE 2110. So on the left-hand side here, we've got an improved version of the remote production solution that I was talking about earlier. This is a web browser-based production switching interface. And in that web browser, I'm taking proxy content, so coded video streams, and I'm producing cuts and mixes based upon that content. I'm then able to capture the time values associated with that content and then replay those decisions against full quality, uncompressed versions of that content in order to produce a full quality broadcast output. On the right-hand side, I've got something completely different, and this is more about the different experiences we can give to end users in the home. This is an example of capturing a weather forecast and associating identity and timing data with it. But in this case, you might note from the top to the bottom, we've got some slight differences. In the top example, we have a very different presenter to the bottom example, given that we've been able to key them against a green screen. The important thing here is that in this top example, that presenter is a signing presenter for the deaf and hard of hearing. And so what we're able to do here is swap out different elements of this composition dynamically based upon this identity and timing data in order to give a complete experience to the end user, an experience that is completely tailored to their requirements, even if they have a more niche requirement or some sort of accessibility requirement. The only way we can achieve these things, however, at least in a way that's vendor neutral, is to have this identity and timing data baked in from day one. So just to summarize what I've been through there, identity and timing enables us to define the workflows that we're dealing with in terms of the content of business value rather than just the systems that are processing it. So the content-centric approach rather than the connection-centric approach. As a result of this, we've got some real possibility to let the IT technology under the hood deal with getting that content from A to B. Worry about all of the detail of plugging together a system, and we just need to tell it exactly what we want it to do with that content from the top level. It's also absolutely critical to make sure that we can make that transition into true interoperable cloud environments. and develop all sorts of new production techniques and products as a result of it. If you'd like to learn more about this specification, the link to it is just at the bottom there. It's available from the same location as all other AMWA NMOS specifications. And if you have any questions, I think I've probably got a couple of minutes left, so I'll be very happy to take them. Thank you very much for your time.
Have you considered using UUIDs as the identifier?
As the identifier, yes, absolutely.
And for derived content, when you do the low resolution things, are those separate streams or do they use the same UUID and perhaps using a question mark parameter list to say what the format is?
So in the particular way that we're doing it, it matches up with what's already happened with the ISO 4 specification. So each of the sources and flows that we identify each have their own unique UUID. And it's that mechanism of having the source identifier and essentially a foreign key into that piece of content that gives us that relationship between them all. So whilst there is additional metadata, so things like the resolution that we attach to it that might help us to identify that, that's sort of an additional piece of metadata that's attached to that identifier rather than something that's baked into the identifier itself. But that's all stuff that's covered within the existing ISO 4 specification. Thank you.
Okay, thank you very much.